Hello everyone, welcome back to my channel. So let's start with question number 4 today. We are given that this inequality should be less than 0. So we are not given a proper quadratic equation over here, but we need to find expression for this quadratic equation. So if I check to make 5 divided by 2x square plus x minus 15 to be less than 0, what I want is, since 5 is a constant, so this expression should be less than 0. If this expression is less than 0, it becomes negative, then the complete value of this function becomes negative and it becomes less than 0. Alright, so for that what I will do is, we'll take 2x square plus x minus of 15 is less than 0. So we'll check for this. The interval that will satisfy this quadratic equation is become negative in that interval, so that makes this function also negative. Alright, let's continue. So if I check, the product over here is negative 30 and sum over here is 1. So if I factorize it, what I get is 2x square and plus of 6x minus 5x minus 15 is less than 0. So I can take 2x common. I get x plus of 3, and if I take minus of 5 common, x plus of 3 is less than 0. So x plus 3 and 2x minus 5 is less than 0. So these are the two factors of this inequality. Now, so if 3 and negative 5 are factors, so what we get, the zeros for this quadratic equation are x is equal to negative 3 and x is equal to 5 by 2. So real line is getting divided into three parts. X is equal to negative 3 and 5 by 2. So we get three intervals. We'll check for each one by one, and we'll see which interval satisfies this inequality. So if we take value x is equal to negative 4, if we substitute it, what we get is negative 4 plus of 3 and negative 8 minus of 5. So what we are getting, negative and negative. So this gives us a positive value, which is actually not less than 0. It will be greater than 0, right? So if I take x is equal to 0, what I get is 3 and minus of 5. So I get minus 15, which is actually less than 0. So yes, we'll take this interval. If I check over here, if I take x is equal to 3, I get 3 plus 3 and 6 minus of 5. So what I'm getting is 6, which is greater than 0. So I'll not take this interval. So interval which satisfies our inequality is when negative 3 is less than x is less than 5 by 2. I hope it is clear. Let's move forward. So now what we have is, we are given two equations. We need that interval which satisfies both the equations. So first of all, we'll check individually and then find intersection of the intervals. Let's check for first equation. X square minus 3x is greater than equal to 10. It becomes x square minus 3x minus 10 is greater than equal to 0. So product over here is negative 10. Sum is equal to negative 3. So x square minus 5x plus 2x minus 10 is greater than equal to 0. X minus of 5 and x minus of 5 is greater than equal to 0. Factors are x minus of 5 and x plus of 2 greater than equal to 0. So if I check, the zeros of this quadratic equation are actually when x is equal to 5 and x is equal to negative 2, right? So this breaks this real line into three parts. So one interval is up till -2, -2 to 5, and then 5 onwards. Now we'll check one by one. So if we take negative x is equal to -3, if I substitute that, what I get is -8 and -1, which is 8 greater than 0, right? Correct. We'll take this interval. Second, if we check when x is equal to 0, if I substitute it, what I get -5 and 2. So it's -10 less than 0. I will not take this interval. When x is equal to 6, 6 minus 5, 6 plus of 2. So it's 8. It is greater than 0. So interval which I am taking is when x is less than equal to -2 and union x is greater than equal to 5, right? So these are the two intervals. So if I write it properly, it is negative infinity up till -2 and union of 5 up till positive infinity. If I check for second equation, x minus 5 whole square is less than 4. If I open this whole square, I get x square and negative 10x and plus of 25 minus of 4 is less than 0. So I get x square minus of 10x and plus of 21 is less than 0. So product over here is 21. Sum is -10. So splitting this middle term, I get x square minus 7x minus 3x plus 21 is less than 0. Right? If I take x common, x minus of 7 and -3 common, so x minus of 7 is less than 0. I get x minus 7 and x minus 3. So zeros are x is equal to 7 and x is equal to 3. So the real line gets divided into three intervals: negative infinity to 3 and 3 to 7 and 7 to infinity. So if I check which interval satisfies this inequality, so if I check for first interval, I take x is equal to 0. If I substitute it, what I get is -7 and -3. So it is 21, which is greater than 0. So no, will not take this. If I check for 4, so we get -3 and 1. It is -3 less than 0. Yes, we'll take this interval. If I check for 8, so for 8, what I get is 1 and minus of 5 and plus of 5. So it's 5. It's greater than 0. So no. So the interval that we are taking is 3 to 7, right? So these are the individual intervals. Now set of values of x for which x satisfies both the inequalities. Now for both the inequalities we need intersection. So 3 comma 7 intersection with minus infinity comma -2 and 5 comma infinity. Alright, so if I check intersecting point, so first interval we don't have any intersection. If we check second interval, yes, it's from 5 up till 7. So yes, we have 5 over here, we don't have 3. So the interval that satisfies both the inequality will be, it contains 5, so 5 and up till 7. So 7. So this square bracket and this round bracket means we are including 5 and we are not including 7. So this is what it means. So if I write it in this in form of inequality, I get 5 is less than equal to x is less than 7. Alright, so this is our answer over here. Let's move forward. Let's solve this inequality first. So product over here is, so for x square plus 4x minus 21 is less than equal to 0. So product is negative 21. And if I check sum is equal to plus of 4, right? So now if I split this middle term, what I get is x square and plus of 7x minus 3x minus 21 is less than equal to 0. I take x common, x plus of 7 minus 3 common, x plus of 7 is less than equal to 0. X plus 7 and x minus 3 is less than equal to 0. So zeros are x is equal to negative 7 and x is equal to 3. So these are the two values of 0. So they break the real line into three parts. So negative 7 and 3. So if I check the first interval, what I get is, if I take x is equal to negative 8. So negative 1 and negative of 11, it gives us 11, which is greater than 0. So no. If I check second interval, I take x is equal to 0. If I substitute it, I get 7 and negative 3. It is negative 21 less than 0. Yes, we'll take this. If I take check the third one, x is equal to 4, I get 11 and 1, which is 11 greater than 0. So I'll not take the third one. The interval that we are taking is, since it is with equality, so we take negative 7 is less than equal to x is less than equal to 3. For second inequality, what we are getting is x square minus 9x plus of 8 is greater than 0. So product over here is 8. Sum is equal to negative 9. So if we split this middle term, we get x square minus 8x minus x plus 8 is greater than 0. I take x common, x minus of 8. I take minus 1 common, x minus of 8 is greater than 0. X minus 8, x minus 1 is greater than 0. So factors that we get are x minus 8 and x minus 1. So zeros are x is equal to 8 and x is equal to 1, right? So real line gets divided into three parts. So 1 and 8. If I check for x is equal to 0, I get negative 8 times negative 1. So it's 8. Yes, it is greater than 0. If I check for x is equal to 2, so it's negative 6 times 1. It is negative 6 less than 0. If I check for x is equal to 9, I get 1 times 8. So it's 8, which is greater than 0, right? So the interval that satisfies this inequality are when x is less than 1 and when x is greater than 8. So if I if I check the intersecting values of these two intervals for satisfying both the inequalities, so one we have negative 7 to 3 and other we are having less than 1 and greater than 8, right? So if I check the intersection of both the intervals, so it's negative 7 and 3 gets intersected with when we take negative infinity to 1 and 8 comma infinity. So if I check the intersection, what I get is from negative 7 up till 1. So this is our region where we get the values of x which satisfy both the inequalities. Okay, so this is the common interval. All right, let's move forward. We get x square plus x minus 2 is greater than 0. So if I simplify over here, product is equal to negative 2, sum is equal to 1. So I can write it as x square and plus of 2x minus of x minus of 2 is greater than 0. If I take x common, x plus of 2 and minus 1 common, x plus of 2 is greater than 0. So x plus 2, x minus 1 is greater than 0. Zeros are x is equal to 1 and x is equal to negative 2. So check the real line, negative 2 and 1. So for the first interval, if I take x is equal to negative 3, what I get is negative 1, negative 4, I get 4 which is greater than 0. Yes. If I check x is equal to 0, so 2 times negative 1, it's negative 2 less than 0. If I check x is equal to 2, so it's 4 times 1, which is 4 greater than 0. So the intervals that satisfy this inequality are when x is less than negative 2 and when x is greater than 1. So instead of and, we can write or. So or represents union. So if I write it properly, I get when negative infinity and up till negative 2 union with 1 up till infinity. So this is the range of interval which satisfies this first inequality. If I check for second product, so x square minus 2x minus 3 is greater than equal to 0. Product over here is negative 3. Sum is equal to negative 2. So x square minus 3x plus of x minus 3 is greater than equal to 0. If I take x common, x minus 3, and if I take plus 1 common, x minus 3 is greater than equal to 0. X minus 3 and x plus 1 is greater than equal to 0. So if I check the zeros for this quadratic equation, x is equal to 3 and x is equal to negative 1 are the zeros, right? So these zeros break the real line into three intervals, negative 1 and 3. So if I check for the first interval, x is equal to negative 2. So what I get, negative 5 times negative 1, that is 5 greater than equal to, so greater than 0. If I check for 0, it's negative 3 times 1, it's negative 3 less than 0, so I'll not take this. If I check for last interval, if I check x is equal to 4, I get 1 times 5, that's 5 greater than 0. So yes, so the interval that satisfies this inequality are when x is less than equal to negative 1 or when x is greater than equal to 3, right? The intervals are negative infinity to negative 1 union 3 and infinity, right? So now for both the inequalities, if I want to check, I will check intersection of these two intervals. So from negative infinity up till negative 1, we have negative 2 over here. So we'll take negative infinity up till negative 2, right? And also round bracket because we don't have negative 2 in this particular case. And if I check for second one, we start over here from 1, but we have 3 over here. So now union with square bracket for 3, we are including 3 till infinity. So this is what we are getting. So if I want to write it in the form of inequality, I can write it as when x is less than negative 2, and I can write or over here when x is greater than equal to 3. So these are the inequalities. Okay, all right, let's move forward. Now if I check this, 2x square minus 3x minus of 40 is greater than 1, right? So to make this or compare it with 1, I can change 1 to 2x square minus 3x minus 40 is greater than 2 raised to power 0. Anything raised to power 0 is 1. So bases are same. Now if I check the powers, x square minus 3x minus 40 should be greater than 0, right? I changed the inequality to inequality of the powers. Now I'll compare it. Product is negative 40, right? Now if I check sum is equal to negative 3. So negative 40 and 3. Now I can split this middle term. So x square and minus of 8x plus 5x minus 40 is greater than 0. If I take x common, I get x minus of 8. And if I take 5 common, x minus of 8 is greater than 0. X minus 8 and x plus 5 is greater than 0. So if I check zeros over here, I get x is equal to 5, negative 5, and x is equal to 8 as zeros. So 5 and negative 5 and 8 break the real line into 3 intervals, negative 5 and 8. So if I check these intervals, x is equal to negative 6. If I substitute it, what I get is negative of 14 and negative 1, which is 14 greater than 0. Yes, we'll take this interval. If I check x is equal to 0, I take negative 8 and 5. So it's negative 40 less than 0. So no. If I check x is equal to something above 8, 9, let's take. That's 1 times 8 plus 5, which is 13. So 13 is greater than 0. So yes, we'll take this. So the intervals that we are taking are when x is, now since it was just greater than, not greater than equal to, so x is less than negative 5 or x is greater than 8. Alright, I hope it is clear. Okay, so I think that's enough for today. We'll continue next question in the next lecture. Thanks for joining.